All right. Today I'm going to be talking about measuring cyclist comfort levels and also trying to model comfort levels. Yeah. So two different things. So basically, I'm kind of pulling two different research kind of lines into one presentation. So it's good. Some of my co-authors and helpers are here, like Ryan. I'm properly going to acknowledge you later on. If you have any questions, I think we're going to do questions at the end. Yeah. So motivation. Just quick comments. A couple of years ago, there was, an interesting paper and research. Actually, Peter Firth came here to the Friday seminar to talk about cyclist comfort levels, and he, developed a method, mostly based on tables to kind of try to determine what would be the cyclist comfort level based on some roadway characteristics and traffic characteristics. So that's what was called level of traffic stress. And, that was in, sometime between 2012, 2013. That's just one TRB reference there. So that's not, even though that became very popular, that's not the only way to measure comfort levels for cyclists. If you know about HCM, is Highway Capacity Manual, it's very popular to measure level of service for vehicles, public transit, and so on. Also has a chapter for bicycles. And actually, the HCM also says that comfort is one of the key elements that determines how satisfied cyclists are with their facilities. But if you go back in the literature, there are 19, 20 different methods to estimate comfort levels. Yeah, that has been done throughout in the last 15, 20 years. So it's not a new concept. It's not something that people had just started to do recently. So one thing about some of these methods, like the one that Firth and Mercuria proposed, was it was based on design guidelines, but it was not actually based on empirical data. So part of what I'm trying to talk about today is how you can collect data to then look at comfort levels and see what the data says about actual stress and comfort on roadways. So I'm very picky at definitions, and a lot of people talk about stress. Some people talk about comfort. In this presentation, it's going to be one the opposite of the other. So basically, if you do the -1, is the other one. So if you go to the dictionary, actually, one of the definitions is comfortable, free from stress. So basically, when we say it's very comfortable, in my presentation, it's going to be it's not stressful at all. So that clarification about the terminology. I think every person that designs a method has to put a different name. So some people start using comfort, some stress, and so on. But at the end, many of the concepts are, fairly similar in terms of what they are trying to do. So the outline, at the beginning, I'll talk a little bit about modeling comfort and collecting data using a smartphone. The second part, I'll talk a little bit about measuring data actually from cyclists as they ride on real-world conditions. And then I'll try to talk a little bit about discussions and implications at the end. So the first part is collecting data using a smartphone. So we were lucky enough to have a project to develop an app to collect cyclist data. And ODOT, Oregon DOT, sponsored that project. And the result of that project was an app that is called OR Cycle. that can be downloaded either for iOS or for Android. And the goal of OR Cycle, one of the things that made OR Cycle different from other smartphone apps that were already existing, like some in Atlanta, for example, was that a lot of emphasis from the beginning was to add questions and try to measure comfort. Yeah. So at the end of each trip, cyclists, when they uploaded the data, they would be asked how comfortable was your trip. So that was the goal, trying to understand the impact also of riding skills and personal characteristics. There is also some user data collection. And another part that I'm not going to talk about today, because it's not the focus of this talk, is cyclists can also report safety and crash data. So we'll focus more on the last line here in the slide. Try to how to use the data to learn more about cyclist comfort. So a little bit about OR Cycle. So a very quick introduction. So you could think about the app having 4 basic elements or parts. One is about collecting trips. The other one is about collecting safety and crash reports. The other part is about collecting user data, and then it has a part with some additional features and links to maps and so on. So the trip questions, basically you open the app, and then this is from the tutorial. Basically, you would say, well, I want to start my trip, and then you would click on Start, and then at the end of your trip, you will have another screen with the stop button where you can stop recording your trip. And after completing your trip, so basically there will be like, the app will be collecting the GPS traces, so the GPS points along the route. And then at the end, the user will be asked about what was the trip purpose for your trip, the last trip you took, how often you use this route, you take this trip. So what factors made you choose, this route, this specific route that you took? And then these are 2 things that are, new that they were not in other apps in terms of one question is about comfort level. So rate your comfort level in the last trip, and also indicate, and this was optional, if there were any safety issues that may have been a concern. Yeah. So and then there is always an option to provide additional comments, and it was nice to see that many bikers used to provide comments, and that was quite useful in some cases. So then the other part is about reporting. Another section of the app is about reporting crash data and safety data. And even though I'm not going to talk much about the results of the data from this, I'm going to say that I'm mentioning this because since November 2015, ODOT is actually receiving all the reports, safety reports only from app users. So when you use your app and you want to report a safety problem, you have the option to send an email to ODOT directly from the app, and that email will be auto-generated. That will include all the questions that we ask. It will include any picture, any comment that you have made, and then the good thing for ODOT is that when they get the email, ask ODOT, so it's the kind of the citizen kind of outreach section of ODOT, they will get an email with a link to a Google map where they just can click on the link and they would open the location where you're suggesting there is a safety problem. So for them, it's much more convenient to get the email than just to someone calling and they don't know the exact location of the safety problem. So they get the exact GPS coordinates of what the user is saying where there is a safety problem. So it's actually convenient for them in terms of making it easier to store the data and to try to understand what the problem is. And the good thing about ODOT is like they have, Ask ODOT has a commitment to reply in 5 business days, and sometimes they provide very, complete, very long and comprehensive answers to questions from users regarding safety problems. This is just an announcement, so it's the announcement of the web page when this was launched. So anyway, going back to the presentation. So the app has other features. Once you record trips, the user can look at the distance, the time, look at the route on the map, and so on. Yeah. So more features, but not the focus of this presentation. So I'm just going to go to some of the interesting things regarding comfort levels. So before doing that, this is just to give you an idea about some of the data we have. This is a heat map providing some GPS coordinates of user submitted data. Yeah. So you can see it just covers most of the main, bicycle routes towards the city. And red and the thickness means more data, and then yellow or green means that there is less density of data in that link. Yeah. So kind of gives you an idea about the amount of data we got. So I think we have millions of GPS coordinates. Yeah. So it takes a lot of time to process all the coordinates. So just to give you an idea, that's a heat map of some GPS coordinates. And so this is not adjusted by trip frequency. Yeah. So one of the things that we did in our app, we didn't want people to say, if you commute every day using the same route, we said, well, we don't want you to have to use our app every day to record the same route. Yeah. So we said, like, just try to record different trips. Yeah. So in many cases, we encourage that, because then having multiple trips with the same data is actually there is nothing new there. So better to have people trying to record different trips than just the same trip over and over that is exactly the same. So that one point about that. So what I was saying about rating the trip comfort. So after you click stop and the app stops recording your GPS coordinates, you will get a question like this one. So basically saying, how comfortable was your trip? Yeah. So then you will get 5 different options. Yeah. So from very good, yeah, and we try to say, well, it's very good. It's so good that this is even good for families or even for children. Yeah. So that level of comfort. Then good. So thinking about most riders will feel good taking this route. Then average. Then we will have bad only for confident riders, and then we will have very bad, unacceptable for most riders. Yeah. Trying to have a very simple 1 to 5 scale that we try to keep this consistent in the app, because the whole idea when we were thinking about the questions was to later on, we wanted to have models where we would take this ordering in terms of comfort and try to use it in the prediction of the comfort model. Yeah. So all this was kind of thought of in advance, trying to think about an easy way to do this. So sometimes you might have surveys where you can ask a lot of questions, or you can have very long options. When you're dealing with a smartphone, you have limitations. One, like your screen has, a very limited width. so you cannot make it too lengthy. The other thing is usually riders, and we tested different questions. It's like people don't want to answer too many questions after a trip. They just want to do 2 or 3 things, and then move on. So it's not like I think we had the option to add many questions after the trip. So we had to be very strategic, very selective in terms of the number of questions we were adding. So that was the kind of the basis in terms of how we collected comfort data. So any user will write, and then after the trip is completed, he or she will rate that route in terms of comfort level from 1 to 5. Yeah, from very bad to very good. So believe it or not, no one had done this kind of data collection before in terms of getting GPS data, so users actually revealing the path they had taken and then asking how comfortable was that. So what we did, because there was no guidance in terms of previous studies, we did a bit of exploratory analysis at the beginning, trying to see how other variables, other data that we are collecting related to comfort levels. And that's what I'm going to be showing in the next slides. So I'm going to be just looking at results first, one variable at a time. Yeah? Because first, we were not sure first about the data quality, and we wanted to see the sign, like say, if you have a variable like, say, trip length, how does that relate to comfort? Does it comfort, make it go up or make it go down? Yeah. So it was more exploratory at the beginning, and again, we did it to test the intuition, that we were getting from the data, but also to see if the results were kind of intuitive. Yeah. So one thing that we were asking at the beginning was, in terms of adding some questions, was some factors that explain the route choice, and I'm just providing some. When you do a model like where comfort is the dependent variable, and each one of these variables is the independent variable, one at a time, I'm just showing if it was significant, then it's shown here in terms of the factors, and then the green plus means that more of that provides more comfort, and the negative red means that provides less comfort. So, not surprising that someone says you chose that route because you have good bicycle facilities that tend to be correlated positively with higher comfort. If the path had a good scenery, also positive correlation. The same thing with low traffic speeds, few busy intersections, if it's good for families and kids. So those are all positive factors, and then the first negative ones were like, I don't know another route, maybe meaning that someone is using that route or that path because it's a captive, kind of doesn't have any other option. Maybe would like to do something else. And then we noticed this, that very, very negative, very, very important relationship between having something that is direct and fast and being very uncomfortable. So I'll talk a little bit more about why this might be happening. There could be some confounded variables that are influencing this. Remember, this is just one at a time. And then there were some that were not significant. So for example, if you say that you found that route on your phone, that turned out not to be significant as a variable. If it's good for a workout, also was not significant. And then if it has other riders, people show no significance. Yeah. So I'll talk a little bit more about good for a workout, because something that we discovered was that trip purpose had a lot to do with comfort. how people feel about how comfortable the routes or the paths are. So, moving on, more variables. In this case, we are trying to link the question about are there any concerns along the route you had just taken and comfort level. So if the users answer not concerned, that was very good indication that it was very, very comfortable, so it was very a strong positive correlation. If they said that auto traffic was a concern, obviously that had a negative sign and significant. And sometimes we got this that was kind of interesting to say that sometimes other cyclists might be a concern, and that also had a negative, in the one-to-one kind of models, a negative sign. So it was interesting to see that, like other cyclists may be also, affecting reducing comfort. Something that was very, very negative was commercial vehicles. So commercial vehicles turned out, was very, very strong negative impact on comfort levels. Other variables, just trying to look at more general, like kind of trip characteristics. So trip distance. So the longer the trip, the more negative the perception regarding comfort. The other thing is weekday. So if the trip was on a weekday, when you compare it with a weekend, also negative in terms of comfort. Yeah. So kind of seems intuitive that during the weekday there is more traffic, more congestion. Maybe your people are rushed and they want to get to a place. Maybe weekend people are more relaxed, less traffic, less congestion. So there might be many factors that will be maybe affecting these signs. Yeah. So trip purpose, and in this case, trip purpose was with the baseline is commuting, then you will get a positive comfort effect when your trip purpose was exercising or shopping. Yeah. So again, that was kind of interesting because, like I said, we didn't have a lot of results that we could have in the literature, but that was interesting because a lot of focus has been sometimes placed on commuters and not on other trip purposes. So it was interesting to add trip purpose to the kind of comfort equation and see what was going on. So, and again, they could be confounded factors here because maybe people tend to exercise more during the weekend or at times when there is not big congestion. So there could be other things that are kind of affecting these results. And shopping errands also may be at a different time of the day, for example. So looking at the bike facility. So having all the GPS traces, then it was possible to geomatch the GPS coordinates to the type of facility that the user was kind of actually travel on. Yeah. So you can kind of assign what percentage of the trip in terms of distance or in terms of actual percentage wise was assigned to that trip, and then we will have these negative signs for no bike facility, arterial, no bike facility, other. Bike lanes also had negative, and then separated path had very strong positive. So again, this is one at the time, and it was more the exploratory part, and there could be other factors that maybe people are using bike lanes when they are commuting. Yeah. So this is just one variable at a time, and what I'm going to show next is what happens when we start to pull variables together and try to estimate models to predict comfort. So this was the exploratory kind of part. We did it for many more variables, but we don't have enough time to go over all the results. I'm just giving you some that will be more relevant later. Now, what happens to the actual comfort levels once you include many types of variables at the same time? So I think we ran many models trying to refine and get the final specification. And something that is important to notice is that we get a rating for the trip, for the whole trip, yeah? So when we are trying to analyze the impact of, say, different facilities, we have two options. One was to include, say, number of miles on bike lanes, yeah? We could add that to the model to say, well, this trip had 3 miles on bike lanes and 3 miles on a separate path, yeah? Or we could model that as 50% of the trip was using bike lanes and 50% was using a separated path, yeah? So we could, basically try to use different variables in terms of how a path was using different type of facilities. So the results I'm showing here in this table are distance-based, yeah? So basically here we took the variables that are related to facilities, and then each trip length will be divided on the number of miles that were actually traveled on different type of facilities. So the other thing about this table is that I'm not showing the p-values or coefficients and so on. I'm just showing at the end, after the model was estimated, these were the significant variables, and then we tried to look at how important these variables were, yeah? And we tried to rank them. So here I'm just showing that in relation to the most important variable, what is the contribution of the others. And the way we did it was after you estimate your model, you get the log likelihood value, and then we were looking at, once you remove a variable one at a time, which one had more contribution in terms of which one is removing more log likelihood after you remove one variable at a time. Yeah? So it's a very simple way to kind of try to get a sense about the impact of the different variables. So there are many different ways to do these rankings. We just chose that. It's a very straightforward, very easy to understand. So what happened? So number one, stress by large commercial vehicles. So that kind of relationship we saw in the one-to-one model, still was reflected in the pool model. And it was, by far the variable that really explained low comfort levels. If you have commercial vehicles and people are concerned about them, then the comfort level turned out to be very, very low. Arterials, with and without the bike lane. So at the end, these two, the variables with and without bike lane, were pooled. The coefficients were somewhat similar. Yeah. So we pulled those together. So meaning that arterials that also had a negative sign originally when we did the one-to-one still remain negative. The third variable was stress by auto traffic. Yeah. Separated path was the first positive variable. So basically the first one showing that the more miles you have on a separated path, the one that's going to increase your comfort level. Stress by other cyclists on the route. And now this became positive in all the models. So basically what happens is that in many of the popular bike facilities, then you tend to have a lot of cyclists. So there is a strong correlation between having a very nice facility, a very nice bicycle facility, and that attracting a lot of cyclists. So that was also correlated when people were saying, I'm concerned about all cyclists, and that turned out to be, again, positive in our model. That was negative when we did one at the time. Then we have trip purpose. So exercising also showed up as a positive variable. So saying that every time you have people that are taking trips for exercising purposes, that are somewhat separated in terms of how they look at comfort levels. And there could be also some relationship between the time when they travel, when they use the facilities, and when they choose to do this activity. So, and this is, again, taking as a baseline commuting, yeah? So when you commute, most people tend to do it at the peak times. And I think what might be going on here is that maybe people like more to exercise when they have the option to do it, and they also tend to do it in times that tend to be nicer to ride on. So greenways, bicycle boulevards had a 76% relative contribution. It was also positive. And we tried linear and square terms in many of these variables. And just to give you a sense what it means when you have in the results some greenways having the direct linear term, and then we had the square one. Basically what it means is that if it would be just the linear term, there will be a relationship that the longer the distance, the higher on average the comfort. Yeah. So when you have the square with the sign that we had, it means that the contribution of the distance on, say, greenways, for example, tends to start flatten out and tends to get to a peak. Yeah. So meaning that you don't get the same increase as you increase the distance. There is a point where that contribution just flattens out. Yeah. So a little bit about that. And then I'm going to show now the results when we did it as a percentage based. So in this case, we were looking at the model, but for example, arterial or other facilities will be included as what percentage of the trip was an arterial. And then we would add, in this case, we could add the trip distance. Yeah. So you can see here that when we did it this way, obviously trip distance became a significant variable and negative, meaning that the longer the trip distance, the less comfort, and that could be interpreted in many different ways. One could be that longer the trip, the more likelihood you have to find something that is not nice. So could be many ways to interpret this. But it was nice to see that commercial vehicles was still the number one variable explaining comfort. Separated path went up, was the second one. Stress by auto traffic was third. Shopping and exercise showed up again. In this case, we had shopping too. And then we have arterials, total trip distance, and stress by other cyclists and not concerned about the stressors were positive. Again, in this case, if you have trip distance, that having the linear and the square variables, meaning that after a certain distance, the impact of distance on comfort tends to level out. There is a decrease in terms of how much is that contributing to the model. So, some key insights. Well, seems fairly obvious that what the users were saying is that we don't like commercial vehicles. That really affects our comfort. And then traffic, shorter routes or distance, seem also to be important. And more bike path or separated facilities. So nothing that sounds very counterintuitive after you look at the results. So the other thing that was interesting to see is that comfort levels were very different as you change the trip purpose. So now I'm going to move to the other set of results. So that was using this smartphone to collect data. Yeah. So people actually, at the end of the trip, providing their feedback. So what about now if we can measure that in a somewhat with some kind of device. So that has been kind of, an interest of mine for a long time. I always wonder how people actually react to different situations. So looking at the literature, we have to go way outside engineering or planning or whatever to try to find something relevant to this. We found that in the psychology and more medicine literature, there were people that had been studying stress levels and trying to measure stress levels. So people would measure stress levels for many purposes, like say, from advertisement, how you like some commercial, is that nice or that makes you feel stressed out, to movies, to computer interfaces, has many applications in terms of what companies may want to know if something they do stress you out. So they have been studied in the literature, but in psychology. So one thing that we decided to try was this GSR, galvanic skin response. So there are many, many papers ranging, again, from psychology to sports medicine, people using these kind of devices. The nice thing about GSR is that non-invasive. So you have a device, and I'm going to show a picture in 1 minute, and then you have some electrodes, and that basically, people have found out that as soon as you start getting a little bit uncomfortable or stressed, then the skin conductance changes. Yeah. So if you have very, very tiny electric currents, and then you can measure how much of that current travel between the two electrodes, then you can, in a way, correlate that to the stress levels. So that's kind of the physiological, basis of the method. So, and this is showing you one of the setup. For this part, it was very complicated. It looks very simple now, but it was actually very, very tough. And again, it's tough when no one has done it before, and you're the first one that has to kind of try to see how this can be done. So we tried to add a lot of things. So we had a smartphone on a bicycle to collect GPS data along the route. We had heart rate sensors, so we wanted in the literature also changes in heart rate is shown to be linked to changes in stress levels. So we also had helmets with cameras, and it was handy to work with some computer science people later on to process the data. Then we had the GRS sensor. Here is attached to the hand. I'm going to show you later on a bigger one. And then we need to have a bicycle, not just any bicycle, but it has to be a special instrumented bicycle where you can measure speed and power. Yeah. So you need to measure power because if you are really trying to go faster or going uphill, that might be increasing your stress level because you are trying harder to do something. Yeah. So that was important to be able to collect that to then, in the results, account for those kind of external influences that are not just traffic related or related to the facility. So this is a picture, that will be the hand, and then you see these are different electrodes, and then you have, that's the device that collects the signals, and so someone would be riding, that would be collecting data throughout the whole trip that the person was riding. And very important ingredient, we had an awesome, not just one volunteer, many volunteers that were helping us. So the human factor, very important. Need to have people that will help us with these experiments. I'm going to show you now the route where we collected data. So we did this route, the same subject, many times, many days, just to get many repetitions of the same subject, and then we had different individuals doing the same route. That's You know what that is? Engineering building. So for us, the center of the universe. That's because it's very convenient. We started our route there at the engineering building because we had our bike and everything there. So then the route we will go down 4th Street. Yeah, and here you have a picture. So 4th Street is mixed traffic conditions. There is no bike lane. Then the route will go Madison and then to the Hawthorne Bridge. Then the route will take us to the East Bank Esplanade all the way here. That's picture of the East Bank Esplanade. And then it's going to take us here to the Steel Bridge. That is the picture here, number 3. And then we will cross back to the west side. We'll go from this part to the Waterfront Park, and then we'll go do some kind of crazy movement here to get onto Morrison, and then 2nd Street, and then Oak. And you see Oak is different in the sense that it has a wider bike lane, and it's a painted green. Then we had Broadway, and then we would, Broadway, again, is a different bike lane. In this case, it's a much narrow bike lane. And then we would use College and then return to the beginning, to the engineering building. So, and this was done during morning peak and morning off-peak conditions, like say 8:30 in the morning versus 11 or 10:30 in the morning. So, some quick insights. I'm running out of time. So, stress levels during, if you average all the measurements of the device during the peak hour, were on average 1.7 times higher than when you compare it to the off-peak. So that was interesting to see. The other thing that we noticed, it was very, very significant. Intersections. Intersections have a huge impact, especially when you compare it to segments. So we would take the center of the intersection, a buffer around the center, and then we would compare that to the segments connecting the intersections, and we would average the measurements, and we would get statistically significant, very significant differences between the segment and the intersection. So that was also interesting to see, and of course the peak-off-peak difference is always there. In terms of the off-peak, significantly less, but not so much in segments when you compare it to intersections during the peak times. The other thing that was really wanted to know more was what type of facilities. So here we have a blue one, peak, red off-peak, and then we are comparing the shared roadway, so mixed traffic, like 4th Street, for example, with the bike lane. Remember, we had on Oak and we had on Broadway. And then we have the multi-use path and 1 and 2 that we divided the Waterfront Park and the East Bank Esplanade. So we, very significant differences too. So actually the type of facility and the type of traffic and the proximity to traffic seems to be making a big difference in terms of what you actually can measure in terms of stress levels. So what else can we learn? Well, we can learn, as we had some of our computer science friends developing some tools for us. We're kind of putting together video with all these measurements, and then we would look at peaks and lows, and then we will have the video to tell us what was happening in the environment in terms of that producing a peak or a low. But I don't really have time to go into the details, so just going to leave a teaser. So on Monday, I'll have half an hour just to talk about this. But just to show you that you can learn a lot in terms of what kind of interactions are really affecting the stress levels. So more on Monday, if you can make it to the Active Transportation Summit. So, some final comments. So one thing is, I think still this is fairly early work, but I think some of the results seem very solid in terms of the intuition and in terms of the signs that we get and how we can separate the impacts of time of the day, type of facility, the type of treat purpose. So I think there are many new insights that we have, obtained from analyzing the data. And actually, I think that two ways of collecting data, a smartphone and actual real world, I think they complement each other. I don't think they provide different things and can be used in different ways. And actually, what would be very nice, and that's my goal, is to eventually integrate them both and then get results from pooling the data. So the smartphone data, I think it's very useful when you get revealed data and some questions that just target comfort. In terms of you get very, you can really get a lot out of the data. And in terms of the stress measurements, also can have very important applications, obviously more specific. So for example, you could compare, different intersections in terms of how stressful they are at different times of the day. You could do before-after analysis, so you could improve a segment or an intersection and then use this kind of real-world measurement and see how actually people are perceiving that improvement, if that's really can be seen in the data. Yeah. So I think there are many potential applications of this. But it still has a lot of challenges in terms of its very, especially the GRS galvanic skin response data. It's it takes a lot of time to collect. It's hard to process. It has a lot of still. It's not like, say, you will just run it and then you will get the answer. It will take to get one answer in terms of before and after, you have to get enough data, enough repetitions, different subjects, and so on. But it's potentially doable. So I think it opens some interesting opportunities for future research. So I cannot end the presentation without acknowledging some collaborators in computer science and civil engineering. So one of them, Brian, maybe you can say hi. He was a key member of the team. His thesis was related to the topic I presented. Many of the results are part of his work. So he was very, very important contributor in the part of the app results, the OraCycle side. The other two students, also from computer science, were very helpful in terms of programming and mapping and so on. Of course, ODOT for supporting the project. Without them, this would not have been possible. Looking at the other research in terms of the galvanic skin response, Alvaro Cavides, he's GRA working with me on that. Robin is also helping with some of the data processing and data collection. And then we have faculty in computer science, Huang Le, Feng Liu, and Wuqi Feng, helping with the video processing because we get a lot of video, and it's very hard to process so many gigabytes of video. So they have been helping us developing some tools, and that was part of the project funded by NITSI, looking at video data and how developing some tools to do that, to try to do applications in terms of bicycle video data collection. So we still have some ongoing work, but yeah, have been very, very good collaborators, and we had they were very extremely useful. So just a bit more. If you want to learn more, just go to our website. There is more information about OraCycle. You can download the app. You can, of course, when you see problems, send safety reports to ODOT. ODOT is going to reply in 5 days. So do that. And then we have some publications, reports. Actual paper with Brian has been accepted for publication. Different papers accepted for publication. We have a paper we presented with Alvaro also about this, and we have papers submitted, several papers on working papers or under review. So there is a lot to gain from the data, so we are very excited in trying to see what else we can analyze. And if you have questions, please, I think we have 10 minutes for questions. So. Yeah.
Speaking about the app, I'm auto civil engineer. Have you looked into integrating other sensor data, like accelerometer, acceleration throughout the trip?
Yeah. So we on that, but the project ended before we had time or budget to analyze that data. So, yeah,
So
we.
So the project has been abandoned,
Well, it's not abandoned. It's just like right now it's the kind of maybe in a transition phase where yeah. So the ODOT official project, has ended, but we're still collecting the data and trying to find a way to find the time and the resources to analyze it. And, yeah.
I looked at the app from transportation class. The app has about 500 users, 500 downloads. How many trips do you get on average?
So the users, you have to sum Android plus iOS. So for the Portland thing, we ended up having around 500 something trips after cleaning the data, removing trips that were repeated and so on. So the results that were shown here, that are actually in the TRB paper, it has between 500 and 600 trips worth of data.
Tom Martin from Community Development. Did you take consider any other demographic, like age, race, sex, gender, things like that?
Good questions. So demographic data, but honestly, we didn't have time to incorporate it into the model. So there were some factors like saying, males tend to be, for example, a little bit more accommodating in terms of how unpleasant circumstances are. So, there were gender differences, age and so on, but we didn't have time to include everything that we collected into the model.
Did the Oregon Cycle app track whether people did a trip with another person or not?
Well, considered initially with the technical advisory committee to include that, but we had too many other factors and questions, so at the end that was not included. But yeah, the answer is we are not including that now.
My second question, did you look at any other signals like
Respiration rate or other easily available physiological signals for stress?
Yeah, so we look at, like say the heart rate, but the heart rate is not as responsive as the skin conductance. So in terms of actual results, it's not as useful as the other method. Yeah. So they are correlated, but it's like your heart takes a couple of seconds until it speeds up and until it slows down. So maybe there was something that happened, but then you see the reaction. There is some lag effect. So that's. But there are other sensors that try to look at other heart functions. They are more expensive and that could be potentially used, but they are not just based on the heart rate. Yeah.
just wonder if that's
engineering. On the second part that you talked about where the volunteers were all instrumented, where did you find the volunteers? Like, were they just normal commuters or more active cyclists? And then I was also wondering if there was any change in the stress with repetition of the route.
So all the stuff, healthy students, so young people, and with the repetition, we didn't see that the number of times you were, repeating the trip would be affecting that more than the environment. The environment turned out to be much more. And also we noticed that distance too has an effect. It seems we need to look at longer trips because it seems like as you get tired, maybe you are more prone to have more stressful reactions. Sorry. Yeah.
It's actually related to both of you guys' questions in terms of demographics. Considering Roger Geller and Dr. Hill's work on cyclist typology, I would imagine that someone who's strong and fearless would have a lot different stress reaction to different sort of interactions than someone who is interested but concerned or doesn't ride at all. Was that taken into consideration?
Yeah. Actually, in terms of, we didn't have the four types typology because something that I should have mentioned, and thank you for asking that question, is that most of the users were experienced, so people that would commute or use bicycle fairly often. I mean, there was a range, from people less to, but. Well, I would say for the app, it was majority were like experienced. We got different type of people, but we didn't include that as a factor in the model that I showed. Again, because we didn't have time to include that, we didn't include any user-specific socio-demographic data in the model. We just wanted to look at initially at trip-purpose, bicycle facilities, time of the day, and any factors that the users might be indicating as potential stressors. So that's kind of next thing to do in terms of adding all those, kind of user data specific.
So I bike a lot, and I do it in the really high traffic times.
Mm-hmm.
But it's never really pleasant, right? High traffic roads, it's just not pleasant. But at the end of the trip, I wouldn't want to drive, right? So did you ever think about those aspects? People who choose transit or driving, add that to the app? It's an additional question. Would you rather have driven? Would you rather take a trip?
Yeah. So I'll give you two answers, one based on the app and one based on measuring actual stress data. So based on the app, we were just trying to get a sense in terms of how would people, rate the facilities, based on the actual trip they had, and in terms of potential stressors, so time of the day, trip purpose, and so on. So we didn't have time to say that what else would you do. The only thing we had that question about, do you have any other option, So we kind of added that as to say, well, are you kind of captive or, you have other options in terms of, but honestly, we didn't have room to include anything like that for, in the questionnaire. The other thing is when we do real-world, on-the-road measurements, we actually do it's relative. So because we actually look at the ups and downs in terms of how people feel. So maybe there is, a vehicle came too fast, very close, and then your stress goes up. So then we look at that kind of change. So even if your average kind of commute, you have certain stress level, what we wanted to look at is to say, well, what are the factors that are really making that stress go up or down? Yeah, and that we can see from the video and from the measurements. Yeah, so yeah, and I think it's already 1 p.m. So I think we need to officially close the last seminar. Thank you.